This is Dr. Hady Lichaa going over the importance of dual lumen microcatheters in coronary interventions. In this case, there was a complex bifurcation lesion where access to the main branch was the most difficult. So the side branch is secured with a workhorse wire. Then a dual lumen microcatheter is brought to the bifurcation. This secures the fact that all the attempts in getting into the main branch would not also lead to loss of the side branch. As you see here, the wire is redirected into the main branch. Another example here is the use of the microcatheter in order to prevent the wire from going back into the subintimal space. So the initial attempts here were made to cross into a micro channel in the mid-left anterior descending artery, but this resulted in the wire going into the subintimal space. So a workhorse wire, non-polymer jacketed, was reattempted to cross into the true lumen without success. You can see here that it's getting stuck into the subintimal space. So a dual lumen catheter is brought over this wire, and then through the over-the-wire lumen, a very floppy non-polymer jacketed wire was used to get into the second lumen in order to avoid this wire going back into the same space as the first wire. Next, we're going to be showing an animation by Asahi. We have no conflict of interest related to this presentation. The Asahi microcatheter tip is 1.5 French, a really low profile. The body is 2.5 French and then 3.3 French in its largest outer diameter, which allows getting through difficult channels. There is obviously a monorail port on which the dual lumen catheter is loaded. Then there's an over-the-wire port that exits about 6.5 millimeters proximal to the tip of the microcatheter. These are animations showing the different utilizations of the dual lumen microcatheter. The first example shows the side branch anchor technique, where the side branch is accessible, but the main branch is either occluded or suboccluded. So a workhorse wire is placed in the side branch. A dual lumen catheter is brought to the bifurcation, which allows not only to secure the side branch from any potential dissection from attempting to wire the main branch, but also provides enough support for the specialty wire to cross through the subocclusion or occlusion. The opposite situation is also doable, like in this animation, where the difficulty is crossing the side branch rather than the main branch. One important technical detail is once the either main branch or side branch is crossed through the over-the-wire lumen, it's important to resist the tendency to exchange this side branch wire for a workhorse wire through the dual lumen catheter itself. As you can imagine, once you remove the RX wire and you try to advance the dual lumen catheter through the side branch, then the tip of the microcatheter will loop on itself and will injure the vessel. So it's important to do it with a separate microcatheter after removing the dual lumen catheter. The next animation shows a technique that's reserved for branches that take rise at an obtuse angle or retroflex branches. Dual lumen catheters come in very handy for these. As all of us know, when we try to wire these with bare wire, even with the smoothest transition between the tip and the body, the wire prolapses out of the branch after a few millimeters of progression. Sometimes angulated microcatheters can help, but I found that this technique specifically is the one that provides the most support for the progression of the wire into the side branch. So in the over-the-wire lumen, the wire is looped on itself, and the entire system is advanced with the wire looped on itself distal to the takeoff of the side branch. Then the microcatheter is pulled back until the tip of the looped side wire engages the side branch, at which point the catheter is pulled back, then the wire is rotated instead of being advanced, and once it gains a few millimeters into the side branch, the catheter is pulled back and then the wire is advanced at the same time. Two particular scenarios where this technique is very helpful is saphenous vein graft retrograde access from the native anatomy and pedoplantar loop access with branches that take rise at a very difficult angle. The next technique also shows the use of a dual lumen catheter when the wire goes subintimal. Instead of parallel wiring with a separate microcatheter, advancing the dual lumen catheter provides significantly more support for the second wire to traverse the true lumen. Obviously, this is operator dependent and experience dependent, but obviously there are other catheters on the American market, including the Enhancer from Biotronic, which is dual lumen. Now we have 3 lumen catheters with the Recross from Biotronic. Again, no conflict of interest with any of these companies. These catheters come in very handy in chronic total occlusion recrossing. And the newest FDA-approved catheter is called Quick Pass by Traverse Medical, which has 3 or 4 side ports in addition to the monorail side port, and in a unique distribution whereby those side ports are distributed along the circumference of the catheter to allow for maximal chances in re-entry. And we finalize with a case. This is a case with a high-risk PCI on the left circumflex artery in a patient with very low ejection fraction requiring mechanical support. Multiple attempts were made at crossing the circumflex even with an angulated microcatheter, but the wire kept prolapsing with multiple catheter and wire combinations, as you see in this example. So the technique of the use of this dual lumen catheter was used. A workhorse wire was placed in the ramus branch, and as you see here, the side port of a dual lumen microcatheter is providing the support for wire progression through the circumflex. Then subsequently exchange for a rotational atherectomy wire for rotational atherectomy of the mid-left circumflex.